Hi class, you will see that in this section is all about the limit. In this section, we'll see how limits arise when we attempt to find the tangent to a curve or the velocity of an object. So as you can see in figure 1a, we have a circle and the tangent line intersects the circle at only one point. That point. Now for 1b is a little bit more complex because 1b shows two lines L and T passing through a point P on the curve C. The line L intersects C only once, but you can see it's certainly not tangent. Now, when we look at line T, it looks like a tangent, but it intersects C twice. All right, so to be specific, we have to look at the problem of trying to find the tangent line T to a parabola. So let's take a look at our example 1. The parabola y equals x squared. It's going to be like this. Okay. Now, we want to find a tangent line at that point 1, 1. So we have the point P here. This is point P, 1, 1. And then we want to find a tangent line. So we're looking at this line. Now, if you remember, to find the equation, we need the slope. And the slope is y2 minus y1 over x2 minus x1. So you see, in order to find a slope, you need 2 points. Now, we only have 1 point, so what can we do? We have to look at the secant line. So the secant line, I'm going to have to look at another point. Let's call it Q right here. And this is the secant line. Now, we're going to choose a nearby point, which is Q right there, x squared on the parabola, and we want to compute the slope. Now, as you can see, this line cuts the curve more than once. Okay, so first let's take a look at the slope of the secant line. So MPQ, secant line, is going to be x squared minus 1 over x minus 1. Okay, so if I randomly pick points, so I'm going to pick point, how about 1.5? Okay, so 1.5, and then we have, we square it. We're going to get 2.25. And then we use the slope formula. We get 2.25 minus 1 over 1.5 minus 1. And then we're going to get 2.5. All right. So if I'm keep picking a different point, so let's say if I pick point, let's say if I pick 1.1. Then 1.1 squared is going to be 1.21. Okay, and then you do the slope one more time. We're going to get 1.21 minus 1, 1.1 minus 1. You're going to end up with 2.1. You see, we have 2.5 and then 2.1. If we keep doing it, you will see that it approaches 2. Okay, so I'm going to take the limit. You can do more point if you want. So if we take the limit as Q approaches P, you will see that the slope of PQ is going to be the slope. The limit is going to be the slope. Therefore, if you take the limit at x approaches to 1, we have x squared minus 1, x minus 1, okay? is going to be 2. So we know the slope is going to be 2. Now finding the equation. So the slope is 2. I'm going to plug it in. So let's say I have y equals mx plus b for a linear equation. I'm going to use p, the point 1, 1. Okay, so I'm going to plug it in. 2 for the slope, 1 right here, plus b. Solving for b, it's going to be -1. Okay, so my equation is y equals 2x minus 1. All right, I just wanna point out that if you make a table to find the limit, so let's say if we pick x, and this is the slope for PQ. Let's say if you pick x equals to 0, the slope is going to be 1. If you pick x to be 0.5, x is gonna the slope is going to be 1.5. If you pick x equals to 0.9, I'm trying to get closer. I'm trying to get x closer and closer to 1. So 0.9, you're going to get 1.9 for the slope, and so on. So if you pick 0.99, the slope is going to be 1.99. As you can see, it's getting closer and closer to 2. Okay? And that's how we find the slope of our tangent line.